How's everyone today? Good. Hopefully the live streaming is working. Just check one thing on our internet connection. Good. Looks like we got both working. So, where are we? We are getting down to the last 3 units. 3 more units and we're done. So in the end of 3 weeks we'll have the course content part completed. So today, after today, there's 2 more meetings where we will go over topics. So today will be Venn diagrams. Next week will be units and conversions, converting between units. And then the final week will be geometry. We'll go over that. And then we have a week sort of open to work on things, maybe work on final projects, go over some of the practice tests, that kind of stuff. And then the last Friday of the regular semester, I think that is May 4th. Yeah, May 4th will be, the whole class time will be allotted for people who want to present their final projects in person. Again, you can also do it by doing a video and uploading it. And again, there's a couple different resources you can use. You can also make an appointment with me sometime out of class, and if you just want to present it in my office, that would be fine. You just need to orally present it one way or another. One creative way was the video was one student last semester did the math of doing a fish tank. And it's kind of hard to bring a fish tank to school, especially hers was a 30-gallon one or something. So it's pretty heavy, and you don't want the fish. So she was able to leave it where it was, take a video, and show us the mathematics of running an aquarium, which was kind of cool. So there's lots of reasons to do that. Okay, let me show you what's new. I uploaded some things yesterday, and there's something I'm working on when we start talking about the final exam. And I want, the final exam is not that great a portion of your test. And you will still be able to earn a good C, and with the extra credit, probably a B in the class without taking the final, before you take the final. And I tell people, don't worry about the final. If you do everything else, it's not gonna get in your way of getting a good grade, even getting an A. And what we've provided, if you go to the modules, and maybe you saw, I think I did put out an announcement. How many of you saw an announcement yesterday? Okay, good. And what I did is up here at the top under resources, as a module section, there's the review problems for the final exam. I had some I had come up with, but another professor came up with these. She was also the one who made the final exam, and her questions are a little bit even more on target to what the final exam is going to have you ask. So it's right here. And then below it she worked out by hand her solutions, so that kind of works you through it. And it does go in order. It goes from chapter 1, I think are like the first 2 or 3 questions, and then it goes to chapter 2, chapter 3, chapter 4. So these first page you might want to skip for a little while. I am also in the process of making videos. I started getting everything set up. I haven't actually posted or made the videos yet, but I'll make them, and I'll see. I find it a little easier to make several, so I may do like 2 chapters in one video, or I may do 1 chapter per video. Do you have any preference? Would it be, should I do like maybe 3 problems and then make a new video, or should I just do a bunch of questions in one video? Okay, easier to find them, yeah. So if you got, then you don't have to try to figure out in the middle where does it start. Okay, that's what I was kind of thinking it might be better, but because it's what's good for you, not what's good for me. Right? So I'll do that. I'll do it chapter by chapter. That's what was kind of holding me back. I said, how should I really do this? So good. Now I can start. So I'll work on those probably over the weekend. And within the next week or 2, certainly next Thursday I have open, I'll get them done. I'll have them up, and you'll be able to work through those. But the nice thing is if you can pull this up, print it out, there's like 44 problems in here. The final exam is 30 questions, multiple choice. So you'll have all the answers, you just have to circle the right one. So, I mean, a lot of times, even if you don't know completely how to do something, you can at least eliminate a couple wrong answers, and then you've got it down to 2 good answers, and you're able to do just fine there. Okay, and you'll see it's a few questions from each of the things we've done, not too much. I think chapter 11 or 12 had the most, but I'll work through these as well. And then there's the answers to them here. Again, just the answers. So you've got the questions, you've got the answers. And then if you go back to the modules, there's the solutions, and those are handwritten, where she's actually worked through them. Again, and I'll go through and provide videos that do the same thing. So what's perimeter, what's area, so that's in there too. And then we'll have some video links. I'll put those up as soon as they're ready, chapter by chapter. And notice, once we finish all the content, there's still a good 2 weeks for reviewing. What I'm doing with the final exam, I'm looking for available times during finals week. So I will actually I'm also substituting for another online class. So I'm going to have 3 different times during finals week that you can come take the final exam. And it'll be administered through MAT141. So the questions will come up and you just choose A, B, C, or D. So at the end of the exam, you'll know exactly how you did, because it will self-score it. And then it puts it in the grade book, and then I'll go forward. So you'll have a good feel for how you did and everything. But I need a computer room, so that's what I'm trying to figure out, where I can get computer rooms 3 times during the week. So I'm looking at doing one on Monday, one on Thursday, and I'm trying to see what other days are available, maybe one on Wednesday, so that you can choose what works best for your schedule and such. And if it doesn't, we can also do it through the testing center. Also, another option available is using something called ProctorU. It's they proctor the exam through your webcam. If you've got a laptop, it's got a camera. It's a whole service. They charge $25 or $30. So if you can come to campus and make it work either through the testing center or one of the testing times, that's the best way, I think, because it doesn't cost you anything. But otherwise, there is that online proctoring, which we can. I'm perfectly happy to set up. But let me know, and again, I'm talking to the people online as well. Let me know if you want that option, because there's a couple things I have to do to get it set up with them. And I'll probably start doing that once we get everything finished. Okay. Any questions while we're here as far as anything in class, final projects, final exams? Everything moving along smoothly? Okay, so we'll go ahead, and I got MAT141. You'll notice when we come into MAT141, this is Unit 10, Chapter 7, Sets and Venn Diagrams. There's the textbook. There's this Venn diagram tool, which I thought would be helpful, but I don't find it all that helpful, but I put it in case you want to play with some Venn diagram tools. But then there's the reading quiz, the homework, and the chapter test. There's videos down here, and I do have a few other videos that I'm going to have to put the link into here as well. So I haven't got those set up, but there is no PowerPoint. There's no class presentation. So what I do with this one is I will present a little bit of the content from the textbook part, and then we'll just start looking at the reading quiz, and if you don't mind, we'll actually even go in and do a few of the homework problems, because there's a few that they made a good use of MAT141 and the visual stuff with Venn diagrams. And the reason I can do this is we'll work through it, so you'll see the process, but when you pull up your MAT141, you'll get different numbers, so you'll have to also rework it. So it's not like we're getting the homework completely done, but we'll see how to do all the more challenging ones. See a coffee cup around here? It disappeared. Hold on. It's probably in my office, right? Okay, so let's do this. We're going to minimize this for now. We're just going to start with a blank screen. Let's go with green. Uh-oh. Okay. Shall we go back? We hadn't been doing the word of the day all the time, but since our technology seems to be working, I guess we could go back to a word of the day. Just to check on things. Anyone have an idea for word of the day? What was the? Anyone see an animal today? You saw what? You saw a tortoise. That's a good word of the day. We're gonna go, could go turtle. That would be easier to spell. But let's see. Tortoise. T-O-R. T-I-S. No. It's got a weird spelling. T-I-S-E. Maybe we better go with turtle. Huh? Anyone in the online world can help us? Yeah. When I see it, I know it, but I know it's also kind of a. It's not how I would ever think to spell it. So, turtle. That I can spell. So turtle. We're going to go with turtle as our word of the day. Which is kind of good because in Venn diagrams, a turtle has a rounded shell, right? So this brings us right into what a Venn diagram is. All a Venn diagram is we'll put a circle, and anything inside the circle has a particular characteristic. And we'll just say that the characteristic, we'll just go with colors, that it's things that are green. Okay, things that are green. So if something's not green, where does it go? Outside the circle. If it is green, it's darker green, it goes in the circle. So green things are in the circle, non-green things are outside the circle. That's all there is to a Venn diagram. Pretty simple, right? But of course in math we like to take simple things and make them more complex. So we're going to see how, but that's basically, if you're in the circle, you have the quality, or you're in that group, you have membership in that group. If you're outside of the circle, you don't have membership, you don't have that quality. So let's switch over, use white. So what if I have two circles with an overlap, which I should use the circle tool, right? Why don't we try that? Forget I have this one. So circle tool, well, they have an ellipse. That's going to be good enough, I guess. Guess we can draw a circle with an ellipse. And then why don't I draw a slightly different color? Back here. So this is now looking more like what we'll be using for Venn diagrams. We've got two circles. And when we have two circles, we could say one is, how about, this is everybody who's taking a math class. And this is everybody who's taking an English class. Let's see, this will tie in. So if I put a mark here, put an X, what do we know about X? They're taking an English class and a math class. So X marks the spot is math and English. Okay. Student Y is over here. What do you know about student Y? Just taking math. So we also know that they're not taking English. Okay. So Y is taking math. And then we'll put Z over here. And what do we know about Z? Just English. Oh, looks like Englishy. Thought I had the just English. Okay. And then there's one more thing that could happen, and what else could we represent? Someone who's not doing anything. So there's this outside area, call them student B, not taking math, not taking English. Could be taking some other classes or not. All we know is that student B, not math, not English. Okay. And so a lot of times with the Venn diagram, what we add is we also add a box around the circles. I've got my angle wrong today that I just can't get the drawings right. But we can put a box around it which represents basically everything. And again, if you're not in the circle, you don't have the quality, but it also tells us that you don't have that. So being in the circle tells us something, being out of the circle tells us something in both ways. So we're going to use these Venn diagrams to do a lot of classification. Anybody taking biology or in biology? Yeah. So we do that a lot with animals, classifying mammals, and then there's subgroups, and there is some overlap down to the species level and stuff. So anything dealing with classification, Venn diagrams are actually fairly helpful too. Can be used for statistics as well. So let's, now I'm going to take sort of a step back. If you look at the textbook, it didn't start with Venn diagrams, it started with something called sets. So I'm going to go now and talk a little bit about sets. We'll come back to Venn diagrams, and then we'll get into actually start doing the reading quiz and see how it's done. Okay, because what we're introducing in this topic is not only Venn diagrams, but logic and notation for logic. So it's like learning a new language. You could look at these symbols, and if you don't know what they mean, it's hard to get started. So we're going to talk about what they mean, and then we're going to do some problems, which is mostly classifying. Is it in the set or is it not in the set? Is it in the circle? Is it not in the circle? Okay, so a little bit on set. So we give sets names. So a lot of times we like to call the first set set A and the second set set B. Okay. And they could be any types of objects. They could be colors, they could be animals, they could be people's names. Anything could be in a set. In math, we'll just go ahead and use lists of numbers. Okay. So we indicate a set with curly braces. And you know how long it took me to be able to draw a good curly brace? That was one of those things I worked on for a while. And that one's not too bad. It's the other one I can't have a harder time drawing. But so we might say in set A we have the number 1, 3, 5, 7. It's not as good, but it's okay. This one, B, is just going to be defined as a set 2, 5, 6, and 7. And these I just made up, so that this, when we get into doing these, this is what we'll be given. We'll be told that these are the sets. We also use a symbol. Sort of looks like an E, but it looks like a C with a line in it. And this means element. What's an element? It's a member of a set. So we might write something like 2 element of B. Is that true or false? It's true. But if we were to write 2 an element of A, is that what true or false? It's false. The 2 is not an element of A. Okay, so again, we get into this logic. Logic oftentimes deals with truth values, so it's true or false. Okay, so that's one question that gets asked. Another question that gets asked in this way is they will use this notation, N of A, and what they're indicating, what do you think the N stands for? Number, and that, you're right. It just means what is the number of elements in A. So even though the elements are themselves are numbers, it's just a count that there's 1, 2, 3, 4. 4 elements. So yes, the number of elements.
What do you do for something like 7 that's in
7 that's in both of them. Well, if we want to know the number of, good question. So the number of elements in B, 1, 2, 3, 4. So it's got 4. So let's talk about what happens when they share something in common. Because what I'm going to introduce now is another thing we do with sets is we actually make operations on sets. When we have just 2 numbers, we can add them, subtract them, multiply, and divide them. That's the math we do. When we have sets, what we can do, the 2 main operations we use is we do A union B, and we do A intersect B. So when we do the union or the intersection, what we're actually getting is a new set. What would you say would be in the intersection of A and B? 7, because it's in both of them. What else is in both of them? Since they're in both, this is what the intersection looks like. It's the elements that are shared. So yes, 5, 7. So that's the intersection. So when they share something in common, that's what's in their intersection. Union is sort of like the additive with everything in both of them. But do you think we would need to list things twice? So what would be in the union? So what are the numbers we'd put up here? 1, 2, 3, 5, but we only need to list it once because it's just the element is in, just saying that it's in both of them. 6, because it's in one of them. And finally 7. So when we get to something called the union, this is also in logic, this is the OR statement. This is OR. It's the inclusive OR. Because the waiter asked you, do you want chocolate or vanilla ice cream? Chocolate or vanilla. What is that indicating? Can you have both? No, it's the exclusive OR. So we use OR in English both ways. If you wanted both, you say, yes, I want them both. That's the inclusive OR. So in math, when we use OR in logic, it's the inclusive. It's an A or B, then we put it together. Okay. The intersection is the logical and. And again, we have to kind of think of this because it's actually opposite of how we use it in English. When we use and, we use it usually in an inclusive setting. I want chocolate and vanilla. But in set theory, the and means it has to be in both. It has to have both qualities, so it's a little more exclusive. Okay. So or is the inclusive or. It's in either one of them or both. And is more exclusive. It has to be in both. It's in the intersecting part. Okay, so those are the words that go together. And again, a lot of what we're going to be working on in the set theory, and we'll use Venn diagrams basically to visualize what this is going on with sets. Okay. There's one more major thing, and then again, that's why I like to get into problems. We've got enough. If we've left something out, when we get to the problems, we'll say, oops, I forgot about that. So then we'll introduce it then. But there's one other major sort of thing that comes up along with union and intersection. We can also do this as a third one. So maybe I should label these 1, 2, 3. Another thing is A with a bar above it. And there's multiple ways to write this. But this means the things that are not in A. Not A. And again, kind of working backwards to figure out what's not in A, what we need, and when we do sets, we use something called the universal set. And again, I might define the universal set to be the numbers 0, 1, 2, ... to 10. So they do this sometimes, they show a pattern. So what are the numbers that are in the universal set? 0, 1, 2. What else? 3, 4, 5, 6, 7, 8. So all the way to 10. So all the integers from 0 to 10. That's in our universe. So if that's the universe, and this is A, what's in not A? Oops. Make that curly brace again. What's in the set not A? Well, 1's in there, but 0's not. So 0's not in A. 1 is in A. 2 is not in A. So notice it's kind of looking for the intersection. 3 is in A, so we don't list it. 4 is not in A. 5 is in A. 6 is not in A. 7 is, but 8, 9, 10 are not. So it's this concept of the complement. 6, 8, 9, and 10. Okay. So and again, we'll use this in a few examples. But just when you see the A with the bar over it, means stuff that's not an A. So with this is how we complicate things. And how we're really going to complicate things is we're not going to have just 2 sets, we're going to have 3. So there are going to be 3 circles we're going to be looking at. We could go to 4, but Venn diagrams get very messy if you try to make 4 circles. So that's why the tool doesn't work very well for more than 3 things. Okay. So far, does it? I think. Any questions? So we've got elements, things that are in the set. We've got number, which is just counting how many things are in a set. So when we have this little this number here, so this is just counting what's in there. And then we've got some operations with sets, which is union, intersection, and not. And that's pretty much it, except it gets a little more complicated when we get 3 items, but we'll deal with it. We'll deal with it. Sort of using an order of operation, working from left to right, parentheses and stuff. And we really only combine 2 sets at a time. So if there's 3 sets involved, we do 2, and then we figure out what to do with the 3rd. Okay, so that's set theory. I think we're ready. We're ready to actually just, that was it. So let me bring back our friend MAT141. And we're just going to head and take a look at the reading quiz, and we will work through some of these questions together. Let's put this up here. Okay, so with this first one, we've got the sets up here. 2, element of A. Well, what's it asking? Well, actually, whenever you have a drop-down list, let's just see, true or false. Is 2 an element of A? No, false. It's not true, false. Is, oh, one thing I forgot. See, that's why we go through these. What's this sideways thing mean? Important thing, but sometimes we just don't want to go too much over it. So this symbol, sort of sideways C or sideways U, means subset. So what do you think a subset is? It's like you're on a team, right? The subset of the players that are out on the field. You're playing basketball, you've got some on the bench, and the whole team is everybody, but there's a subset that are actually actively on the court at any time. So yes, it's a smaller group that's within there. So we're looking, B is 7, 8, 9. Is it a subset of A? Is it a smaller group than A? Well, 8 and 9 are in A, but 7's not, is it? So it's not a subset because of the 7. Had it just been 8, 9, then we could, we could say C is a subset of A if we define C to be the set 8, 9. But in this case, what do we have to say about B being a subset of A? It's also false because of the 7. It's got 2 things that are in A, but it's got 1 thing that's not in A. Does that make sense? A little bit more. And we got it all correct. Okay. So that's one step. And this time they're going to give us a universal set, which, I don't know, they use the letter S. Sometimes we could use S, we could use U. I like U for universal. Here we have set A, set B. List the elements in set A and set B. Now, does anyone remember when we use the word and, is that union or intersection?
Question.
Yes.
Mine says it's a math processing error.
A math processing error.
Yeah, like it won't give me the set of numbers. I don't know why mine's weird.
So on question 1?
It's very like, no, just all of them. What I've been trying to do. It's like, mine is like super old fashioned. Yours looks like really new.
What browser are you using?
I'm on the internet, so I'll have to use Chrome, right?
Yeah.
Okay.
Chrome or Firefox. Firefox is a preferred. I'm using, what am I using? Safari. So that works. Sometimes if you use Internet Explorer, sometimes it's, I think that's probably it. It's a browser error thing.
Okay.
Because yeah, you should be able to, because these get randomly generated. So I'm sure, yeah. So for this one, what we're looking for A and B, this is really A intersect B, the one that's in both. And so 2 is common, 3, 4, 5, 6, no, 5 is not there, and 8 is common. So would you agree that what's in there both, what's in A and B is simply 2 and 8. Does that make sense? Okay. A or B, now remember that's the one that's inclusive. So that's really, the intersection is the other way to write it. The union, this is the way to write it. So it's everything in A and everything in B, and any overlap we only listed once. So that's what that means. It's the inclusive. If you're in club A or B, you get a B in this set. So that's going to be 1, 2, 3, 5, 6, 7, 8, 9, and 10. Does that seem right? Okay. And there's a video helps if you needed them. I'm not sure what they give us, but let's see if we got it right. We'll submit it. And it liked what we have. So that's sets, intersections. Okay, so again, and we didn't use the universal set last time. It looks like we'll use it this time. So we've got the universal set, the numbers 1 through 10. A are just these numbers, B are just these numbers. Okay. Then again, here it is. It wants the elements in set not A, right? That little bar on top means the ones that are not in A. So we have to compare A to the universe, and we write the ones that are in the universe but not in A. So 1's in there, 2 is not, 3 is in there, 4 is in A, 5 is not in A, 6 is not in A, 7 is not in A, 8, 9, and 10 are all in A. So we just were able to pick out the ones that are not in A. And that's usually the hardest part of this, is you're just going to be comparing and then understanding what the notation that they use is. Make sense? And then what's not in B? Again, we're comparing B to the universe. So it's everything that's in the universe, but that is not in B. So we can see B starts with 5, so we'll have the numbers 1, 2, 3, and 4. 5, 6, 7, 8's in B. So then we must pick up at the other end with 9 and 10. Okay, so that's the 2. Oh, they want more. Let's pull this down. Oh, they got a lot of stuff for us to do. But not too bad, right? So list the elements A union B. Union is which? Is that the and or the or? It's the or. So it's the inclusive or. So anything, so I just start with maybe A and start listing it. And when I see something in B that's not an A, I list it as well. So we just start listing the elements of A. 1, 3, 1, 3, 4, and then I say, oh, 5 is in B, but it's not an A, so I'll list it. And then 6 is in B, 7's in B, 8's in both of them, I list it once, and then there's a 9 in A and a 10 in A. Okay, so that's in the union. We throw them all together, but we don't have to list the ones that happen in both of them. We don't list them twice. Okay. The intersection, again, that's going to be the ones that are in both. So I'm kind of comparing 1, 3, no, 4's not in B, 5's not in A, 6 is not in A, 7's not in A. Oh, here it is. 8. 8 is the one element that's in both of them. So if we look at the intersection, it's only got one element, just 8. 8 is shared. Incidentally, if they didn't share anything, what would be in the intersection? If there's nothing in common, what would be in the intersection? Nothing. So it's an empty intersection. And I'll just, over here, if there's a possibility when you have two sets, and we'll use them too. So I'll just use D and C, which are just two sets that I made up. If the intersection's empty, we write that empty set. So you might see this symbol. This means the so that's a possibility. We'll see what they have us right here. Okay, and I think all that's left now is to check our answers by submitting, and we got them all right. Okay. And just, I'm not sure if I mentioned it before, bless you, but in Math AS, you know, sometimes if you're not even sure what the answers look like, you could just come to a question and hit submit 3 times and it'll give you the answers. And sometimes once you see what the answers look like, you can kind of reverse engineer it. Maybe some of you have already been doing that. Now, with this one, since we have this in front, what are they asking? The number. So we're just counting how many elements, not what the elements are. So, and we'll go through a few of these. These ones at the end, we can actually do some math to calculate them rather than setting them up and counting. So the number in A is 1. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 elements. So that's what goes here. So watch this though. How many are in S? So we got all this dot, 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 but 1 to 20 is how many elements? 20. You can count on your fingers from 1 to 20, and yeah, you get 20. So 20 elements. So let's think about this. If A has 11, and A is got to be a subset of the universe because the universe is everything. So if A has 11 and the universe has 20, what must not A have? 9. So yes, we can do math this way. We say, well, the universe has 20, A has 11, so the complement is what's left over. There must be 9 that are in not A. So this was the number in A. This is the number in the universe. So we subtract the 2, we should be able to get the number in A. And we'll see, in fact, that's what happens. How many are in B? Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B has 12. A intersect B, what do we have to do for that? What's that? What's in both of them? So we yeah. So they have a 2 that's shared, they both have 3, they both have 5, 6, 9, 10. Looks like the 11 is shared, the 12, the 14, not 15, but 16 is, 17 is not, 19 is. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that one we did have to count. What did I say? 8? Okay, again, your numbers will probably be different, but we'll count them. Now watch how we can get A union B. We could construct a set of A union B, remember them, but we would not put the ones that are shared in there. We'd only put everything in there once. But here's another thing we can do, and actually I think we did this when we were back doing the probabilities. For this union, we can take the number that are in A, add to it the number that are in B, but if we just add them together, what we've done is we've counted the shared things twice. So how could we uncount those? What's that? Not quite. We divide by 2, we get half of what was in there. But it could. This would work if there was no overlap, if there was nothing in between. But what we have to do, subtract off the number in A intersect B. Now, thinking back to probability, we didn't always use this, but this was actually in Chapter 9. We used this concept back in Chapter 9. So we would have a number in A is 11. It's right up there. The number in B is 12. And notice if we just add this together, we get 23, which is more than what's in the universe. But what we need to do is subtract off the intersection, the shared ones, because those 8 got counted twice. So we subtracted it off once, and so now everything's only counted once. So that's going to be 23 minus 8 is 15. So that's the way to do it. Again, you could actually construct A union B, make that set, and then count the items if you wanted to. And you'd see there is 15 in that shared set. So far, so good. Let's check it first. I think I could just hit enter, right? Yeah. So got them all right. Did it for us. Good. So clear off our screen. And go to number 5. Okay, so this is a Venn diagram. Consider the Venn diagram shown below and select the best answer. So the only way we know, just let's see what the answers are. So A is a proper subset of B, B is a proper subset of A. Which one is the subset? The smaller one. Good. It's contained within B, and it is a subset. There's nothing of A that's outside of B, so it's definitely a subset. Now, let me also define what a proper subset is. A proper subset is that it's actually not the whole set itself. Okay. If A and B were the same set, we could still say they're a subset, one of the other, but it's not really a proper subset because they're really equal to each other. Okay, so a proper subset is actually smaller than the whole set. Again, this one you could probably guess, and if you got it wrong, you just try it again, but because there are only 2 answers. But that's the concept we want you to have down: is a proper subset is contained within the larger set. Like you here today are in Math 141. You are a subset of the students at SCC. You are students at SCC, but not every student at SCC is in this class, so it's a proper subset. Very good. Okay, so now we're going to start using Venn diagrams and sort of tying it in with this set notation. So instead of what this number is that when I have 3 here, what that's indicating is that's the number of items. We don't know what the items are in set A, but we know that 3 of them are here, 9 of them are here, 10 of them are here, and 7 of them, there's 7 elements out here. Okay, so these numbers are not the elements themselves, but they're how many elements would be out there. The elements could be letters, they could be social security numbers, they could be telephone numbers, they could be anything. Okay, so what's the number in A? Good. It's everything inside this circle. So there's 3 here and there's 9 there. So we're going to get 3 plus 9. So I'm going to go through and then we'll come up with the answers. What's the number in B? 10 plus 9. What's the number in A intersect B? A intersect B is this sort of football-shaped region here, just the 9, right? So we don't actually have to do any math there, we just recognize it. A union B, everything in A with everything in B, but we only count the middle part once, okay? So that's what the beauty of having this visual is. It's going to be 3 plus the 9 plus the 10. What's the number not in A? Again, we can do a visual. Here's all the stuff that is in A. So the stuff that's not in A, 10 and 7. Finally, the number of things that are not in B, all of this is in B. So we're looking at 3 and 7. For the things that are not in B. So see how the visual of a Venn diagram can be very helpful once you start to understand, because we're looking at regions.
For the number of A union B,
Yes.
why are we adding the 9 as opposed to subtracting it?
If we would, okay, that's a good question. Because last time we subtracted it, right?
Mm-hmm.
But last time we counted it twice. So I'll show you how we would subtract it. So if, like the number in A is 3 plus 9, that's 12. Number in B is 10 plus 9, which is 19. So the other way we could do the union is we could do the number in A plus the number in B, and then we would subtract off the 9, okay, because we added it twice. But with the Venn diagram, we were able to actually only add the 9 once. So with this method, we just counted the regions. We never had to subtract it off because we counted the intersection only once, because the visual allowed us to do that. The last time we didn't have the visual. So you'll see that these two numbers are the same. That's what, 1922? That's what it ends up being. So if we do the math on these, we've got 12, 19, 9. And again, if you do both of these, you should get 1922. You do this math, and this will give you the same. Gives you 22. The number not in A, 17, and the number not in B, 10. But with Venn diagrams, we're able to do it all just by looking at the regions and being careful not to double count something. Does that make sense? Questions? Okay. Submit it. Looks like the video is still going after the last couple weeks with all the problems. A little bit of, hopefully it'll just keep going. Okay, so now this is where we're going to expand off a little bit. We're actually going to get to make a few, we're going to use Venn diagrams with this question. And I'll show you how that's done. Okay. So first of all, when I do a math problem, I like to start at the end and see what the question is, because at the end is the question mark. So we want to know how many own neither a cat nor a dog. Okay. So we're counting non-cat owners, not dog owners. So that helps a little bit. So we come up here and we start looking at the numbers. We've got 116, we've got 18, we've got 77, and we've got 9. From this question, we know that we're talking about pet owners, and we know we're looking for dogs and cats. 18 said they own a dog, 77 said they own a cat, 9 said they own both a dog and a cat. So what we can do here, we'll go with our circles again. Let's see, what color circle would be good? Let's go with dark blue. So make a dark blue circle here. And one here. So overlap, maybe not that much. So we'll make one circle for dogs, one circle for cats, and let's see if we can put this information in here. When we're doing Venn diagrams, and I learned this the hard way, by doing it the wrong way for a long time. What you want to do is if you can fill in the intersection part first and work outwards from the intersection, it'll be better. You'll just see. So what's the intersection? The intersection is people who own both a cat and a dog. How many? 9 said they own both a cat and a dog. So if we put our 9 here in the middle, then when we come back to the 77 that said they own a cat, where do we put the 77? Here? Not really. Because these 77 who owned a cat, these 9 also own a cat. So they're in the 77. So what goes in here, 77 minus the 9, because these 9 are cat owners, so they're actually included in this often. It doesn't say they only own a cat. So this, you got to be real careful with the logic. So what goes in here is 77 minus 9, that's 68. I think 68. And then back here, 18 say they own a dog. Again, 18 doesn't go in here because that includes these 9 also are dog owners. So again, we have to do a little math first. We take 18 minus 9, and that's what goes in here. So 9 are here. So notice 9 and 9 is 18. There's 18 dog owners. 9 plus 68 is 77. There are 77 cat owners. And it's separated out that these 9 in the middle don't get counted twice. But what's missing? What have I not done yet? We haven't figured out how many are out here who don't own a cat or a dog. And what I do know is that there was 116 were asked. Those are just pet owners. It could be, maybe they own a snake, a mouse, a guinea pig, a bird, anything but a dog or a cat. So the way I figure out how many are out there is I take those 116 and I'm going to subtract off this total here. 9 plus 9 plus 68. So do 9 plus 9 plus 68. So you kind of see that you need some scratch paper going around here. What does that give us? That's 77 plus, that's 76, 86, right? So 86 are accounted for up here. Subtract it off. 6 minus 6 is 0. 8 from 11, 3. So there's 30 pet owners out here who do not own a cat or a dog. And again, if you wanted to, you could put a box around this. So these 30 are the pet owners. How many owned neither a cat nor dog? Bless you. There's our answer right there. Okay. Now, you probably could have gone through this some other way and figured it out. But what this method with the Venn diagrams does is it really helps break down the different groups. And you're going to see it's really helpful when we have 3 different groups. And we're going to get there. Okay. But always start in the middle, work your way out by doing these calculations. Subtract off what's already been counted. If you work from the outside in, it's what you end up doing is you do the same thing, but you have to erase a lot of times. If you put the 116 out here and then you figure out, you know, you would have put the 18 here, then you would have had it erased and put the 9 here. So work from the inside and go out. And especially on these next ones we're going to do, you'll see the need for that. Okay, here's another one. And now notice there's a multiple questions, so this one, making the Venn diagram, is really going to help us answer these questions. And there's a survey, and these are the options. They're coffee only, tea only, both tea and coffee, neither tea nor coffee. How many circles do we need to represent this question? Well, we can deal it with 2 because there's really only 2 options, coffee or tea. Both coffee and tea will be in the intersection, and neither coffee nor tea will be outside of the circle. So we can do this with 2. But before long, we'll have at least one example where we have oops, what did I do? There we go. Clear that out. Two circles. We'll call one of them coffee, the other one tea. This intersection is coffee and tea. So where do we always want to start? In the middle. Right, start in the middle. So we've got our numbers. We've got 228 people total were asked. 80 said this, 36 said that, 40 said that. So we want to go to the place where they have both, the middle. So 40 goes right here. That's the easiest part of the whole problem. Now everything else will require some subtraction. 36 report coffee. Oh wait, actually, do we have to subtract? Coffee only. So do we have to take 36 minus 40? Well, that would give us negative people anyway, right? So they're kind of being nice here. Coffee only, that tells us there's 36 right here. So they helped us by the way they kept it. 80 reported tea only. Ah, nice. Where does the 80 go? Right there. We didn't have to subtract because they broke it out for us. But how many go outside the box? We have to kind of add these 3 together and then subtract from 228 for people who don't drink. Maybe they drink orange juice or something, right? So 228, and this is 36 plus 40 plus 80. Just do that down here. 36 plus 40 plus 80. Add those together. We get 6. This gives us 7, 8. That gives us 156. Do the subtraction. We get 2 here. 5 from 12 is 7. 72 are out here. They drink something other than coffee or tea. So notice how with all this information we were able to come up with this. So how many people drink tea in the morning? Is that 80? Tea drinkers, because they drink coffee and tea, but these 40 also drink tea, so there's 40 plus 80. I guess I should write those out. Plus 80, so that's 120. How many people drink coffee? 36 plus 40. And then how many people drink neither tea nor coffee? And we've got that because we calculated the outside, that'll just be our 72. Come back here, put in our totals. 76. So notice this is, the mathematics involved here is really just adding and subtracting. But we're doing it by regions, and again, it can get a little complicated, but you can also keep up. Okay. Here. Submit. There we go. We got it all right. Okay. So we'll take one more look at one more problem in the reading quiz, and then I think I'm going to go to the main homework because there's a couple of challenging problems I'd like to kind of have us work together so we see a little bit of sample of each. Because these video links, sometimes they have something that's a little more helpful, sometimes not, but this way you'll have something to revert back to. Okay. So this one. How many circles do we need? So yeah, this is only still a 2-circle thing, right? So people are using either Twitter, Facebook, or using both. So again, we can draw 2 circles. I'm getting better at drawing circles with this program. And we label one circle Twitter, the other circle Facebook. The middle region is those who do both, and the outside is those who don't do either. Okay, so just you're either in the circle or you're out of the circle. So we've got numbers. We got 34% surveyed have used Twitter, 74% have used Facebook, and 18% have used both. So where do we start? In the middle with those who have used both. So now it's not 18 people, but we'll recognize that these are percentages. So there's 18% there. So if we're using percentages, what should everything total to? 100. Good. So 100 is our basis on this thing. So now that we know this part, how many do we put in the Twitter part of this circle, this part of the Twitter? We've already counted 18%. 34% are totally in here. So does it make sense that we're going to have to take 34 minus 18? Again, these are percentages. And 8 from 14 is 6. 1 from 2 is 1. So 16% are here. 16 plus 18 is 34. The Facebook users total is 74, but we've already counted 18. So again, we're going to have to take 74%, subtract off the 18% we've already counted in the middle, because they are not saying Facebook only like the last one, so they're not as helpful. Again, 8 from 14 is 6. 1 from 6 is 5. So now we've accounted for 56 out here. And then we can get the total, which is going to be 100% minus the total of 16 plus 18 plus 56. 56, 18, and 16 added all together. It's 12, 20, 7, 8, 9. That's 90%. So 100% minus 90%, 10%. So there's 10% on the outside. Does that make sense? And again, these could be answered without a Venn diagram, but Venn diagrams are a nice way to visualize the problem and make sure you're getting things counted correctly. So, for reading quiz. Done some like this. What I want to find is like a 3-circle Venn diagram. Here we go. So, now this one has already been set up for us. So there's a couple questions like this where they give us the Venn diagram, and then we just have to answer some questions from it. There are some other questions where they actually have us create the Venn diagram, and that's what the question's grading. Let's see. Move this up a little bit. Yeah. Okay. So remember, all of these questions are going to involve probably some sort of adding or subtracting to figure it out. But basically what we're going to do is identify regions. So in our 3 circles, we have, we have parents, we have men, and we have currently employed. Now, when we talk about parents, what's a parent? There's 2 kinds of parents in the world. Those who say yes and those who say no. No. There's 2 kinds of parents. We have words in English for them. What's that? Mom and dad. So there's a mother and a father. Those are the 2 types of parents we've got. Can anyone tell me what kind of a parent are these 13? What? Let me ask this. These 5 parents, what are they? They're dads because they're also in the men's circle. These 13 are not in the men's circle. So it's sometimes harder to remember that when we're not in a circle, we also know some information. So these 13 are not men. They are parents who are not men. They must be the mothers. These 7 are also going to be mothers. These 15 are going to be fathers. So those are the kind of under the surface type definitions that we use here. Okay, currently employed, not much. So how many people at the party are parents? So what do we count? Everyone in the green circle, whether they're mothers, fathers, or employed or not employed. So for this question, it's going to be, we're going to take 13 plus 5 plus 15 plus 7. And notice we didn't count any of these twice. They are in separate regions. But we counted everything inside the green circle, the parent circle. Okay. And we'll do that in a moment and fill it in. But this is the method we go through. That's what we need to add. We're adding these regions. So hopefully you see where I got the 13, 5, 15, and the 7. How many people at the party are fathers? Again, what is a father? It's a parent who is a male. So we need to find the intersection between the men and the parent circle. So there's these 5, and there's also these 15. Okay. So it's just going to be 5 plus 15. How many people at the party are working mothers? So they have to be working, so they're currently employed, so they're in this pink circle or red salmon circle, whatever color that is. And they're also in the parent circle, but they're not in the men's circle because that's what makes them a mother. who do we have to count for that? The working mothers are right here. Just these 7. Okay, they're not these 15. These 15 are the working fathers. Okay, so in this case, no real math except to know which region to count. How many women are at the party? To count the women, what do we have to count? Everything not in the men's circle, even these 11 out here. These 11 are women who are not parents and not working. Okay, so we're going to count everything outside of the blue circle. So we'll start here with 13, 7, 14, and 11. And now the time is to do the math, enter the answers, and we'll do a check. Has anyone got this one yet? What did we get? 20, 33, 40. Wasn't too bad. If you group things, try to group things by tens, sometimes it helps the calculations go a little easier. This one's not 5 and 15. That makes a nice grouping of 10, so we get 20. This is a nice easy calculation, so we'll just do 7. And then down here, again, 13 and 7 is 20, 34, 45. So practice on your addition facts. And then I think if I just hit enter, it will tell us whether we're right or not. And yes, we got it all correct. Okay. So you see, this is why I sort of do this part towards the end, is once we've got through the probabilities, these last few ones, this last unit, really the math is either adding or subtracting, but it's knowing what parts to add or subtract. Let's see, which one? Is it this one? Okay, here's another one. Again, they ask a lot of questions. They've got the Venn diagram, women and parents, but just 2. So you're going to do the same thing. These 18 parents are the fathers. Okay. These 13 are men who are not fathers. So I'll let you work on those. I'd like to do one where we have to actually create the Venn diagram, and I think it's this one. We could do that one, but there's one that we actually fill them in. Maybe they got rid of it. Let's see, 21. Yes, here it is. This is the one I wanted to do together. Again, you may have slightly different numbers. Let's go through this one, and then I think you're well set to at least address everything. We've addressed pretty much. I'm going to make the screen a little bit. Let's move this up. Actually, I think what I'll do is I'll make it just a little bit small. There we go. We all fit on the screen. Okay. So, the question's asking, we've got all this information. We've got to fill in this box. And remember, it's basically, if we start in the middle, working our way out, we're just taking the numbers and we're subtracting off as we go. Okay, so that's, we'll kind of do we got space to do some calculations here. The middle one is always the easiest. So with that in mind, we look, and oftentimes I'll do it, we want them that are taking 3 courses. So there's a science course, history, and English. The ones that are taking all 3 are 360 students. So do you agree with me? Those all go in the middle. And if you start there, this is the easy way. I always started from the top and I worked through it, and I'll tell you what, you might want to try that once just to see how much frustration there can be in doing these. Maybe you don't have enough frustration in your life. I don't know. I think I have enough in mine. So This is the simpler way. Start in the middle, and then now as we work out, we go around. Okay? So we come back to this next, science and history. Where does that go? Science and history, it's the intersection of those who take science and history. But notice we've already counted 360 of them here. These guys, these 360 are taking both science and history. So to calculate this is slot number 2. We have to take this 597 and subtract the 360. Okay. And calculators are great for this. But I'll just 237. So we can put that in there. We go up to the next one, science and English. Science and English, so that's going to be this part. Again, 360 have already been counted. These 360 do take science and English. So we have to take the 633. So this is going to be slot IV, which is also the Roman numeral for 4. We're going to take 633. We're going to subtract off the 360. And we get 3. 6 from 13 is 7. 3 from 5 is 2. 273. And these can, see, the problem with this is even when you're doing things correctly, if you make an arithmetic error, sometimes they're hard to come back and find. So that's why it's good to have well-organized scratch paper. Because even when you're doing this in this method, it's it's easy to make mistakes. So this region is going to be history and English. History and English is up here. So this is going to be region 6, BI. We have a total of 752. But we subtract off the 360 we've already counted. So 752 does not go there. We have to subtract off the 360. Because they've already been counted. So we get 2. 5 from 15 is 9. 6 up here, 3 from 6 is 3. 392. And now it even becomes a little more tedious because as we go further out, we're subtracting off both of these. But now we can come back and we can refer to the ones we've already counted. Okay. So to get those who, let's see, I guess working from the bottom to the top, the next would be English. English is right here. So this is Roman numeral 8. Which is English. What we're going to do is we're going to take the 1,276 students who took English, but that's everybody in the circle. So we have already counted 360 plus 273 plus 392. You see how these it gets tedious. We have to add these 3 together and then subtract it from 1276 to get the total that took only English. Okay, so to do that, 273 plus 360 plus 392. Notice those numbers don't appear up here. We'd have a difficult time trying to just do it without these Venn diagrams. So we add these together and then subtract that from the final. So there's 5. That's 16, that's 22. 2, 4, that's 9, and 3 are 12. So 1225 we've already counted. So subtract that, the 1276, we get 1, we get 51 people that go right here. And we're going to do the same with the history, same with the science. And again, it just gets tedious because now we're adding these three together, but they're a different three. Okay, so to answer for question number 3, which is here for history, 1, 2, 3, we have to add what's already been counted, 237 plus 360 plus 392. And you might find a quicker approach by using some of the other numbers, but and that's fine. 9 and 9 is 18. That's 6, and another 3 gets you 9. 989 are all the ones we've counted in here in these 3 regions, and history has 1,222 total students, so we subtract off the 989, and 9 from 12 is 3, 8 from 11 is 3, and 9 from 11 is 2. 233. I'll tell you what, I'll be very surprised if I haven't made an error here. Hopefully someone's watching and double checking me, because that always helps, because that's just frustrating to get to the end and where did I make my mistake, right? And as we get further out, if we made a mistake inside, then we oftentimes we'll make 2 errors because we're using wrong errors for the calculations. You say adding and subtracting. Great place for calculators. 2 more calculations to do. The science folks, well, that's I. Kind of running out of room here, but we'll see if we can't squeeze it in here. Maybe we'll go over here. I think we can make. So number 1 is those who did science, and see if you followed it and you started to start with this one and work through it, it's just going to be harder. Like I said, give it a try. If you can handle the frustration. So it's 116 we're taking science, and we have to subtract off these 3 numbers here. So 237 plus 360 plus 273. 237, 360, 273. Add those together. 10 carry the 1. 13, 16, 17, 1, 5, 6, 7, 8, 870. So we'll take 870 away from the, so we get 6, 7 from, let's borrow, 7 from 11 is 4, 8 from 10 is 2. 246 should go right here. And then finally, we need to fill in this last square here. And how do we do that? Well, there was a total of 2,392 students. So what we have to do is we have to add everything that we've counted so far. And could you find a quicker way? Well, you could. You could start with, say, English. The whole English circle is going to be 1,276. So that's the English circle's been counted. And then we need to add the ones we haven't counted yet, so maybe 237, 233, and 246. That would do it. So it saved us a little bit of time. 233, 237, and 246. And my brain's getting tired of adding and subtracting. Has anyone got a calculator that they can run those numbers for us? Maybe if we can get two people to do it, and we can check, because if two people get the same answer, that's usually a good sign.
I got 1,992.
1,992. Okay. Let's hope it is right. If it's not, well, I'm going to cry, I think. There's nothing else left to do, right? Oh, shoot, we missed something. Which doesn't surprise me when we do all of this. What did we miss? We're lucky if it's going to be the last. Oh, really? I got the English one wrong. So notice how if you miss one, so it was at the end, this 51 shouldn't be 51. So that's why this one's wrong. That was the English. Fortunately, I did label these things. So that was this one. So it should have been 273, 360, and 392. And then the English was 1276, so this is correct. So there must be something wrong with my arithmetic here. Probably it's over here. So that's 5. This is 13. Oh, it's 22. Carry the 2. 2, 4, 7. Oh, it's 4, 7. That should be 10, not 12. So, not too bad of a place. So this, I had 12. It should have been 10. You agree with me? Check the numbers again. So that's 10. So that means this should be 10. So the 51's okay, but 0 from 2 should be 251. So we can change that one. So it's not too big of an error. Put 251. So that means our number here is 200 too much, right? Because I counted, actually, I still should have, because I counted this, all of these are right. I'm not sure why this one's, these numbers should be right, because I didn't use this number. I used the 1276, 233, 237, and 246. Oh, I made a rookie error. That's the total. So see, we go through here, but these are the same type of errors you might make yourself. This total was 1,992. That's the total inside the circle. To get the total outside the circle, we have to subtract. So that was my fault. If I would have went through the right way, we probably would have got the right. So we're going to take that and we're going to subtract it. How many total were there? There were, we'll have to look up. There were a total of 2,392. So, yeah. 2,392, and we're going to subtract off the 1,992. That's kind of a nice number. 400. Okay. So notice we took this and subtract off the number in there. Should be 400. Okay. So one arithmetic error and one just not thinking clearly error, realizing I needed to subtract at the end. But if I can do it, you can do it. I mean, make mistakes. But we can also learn from our mistakes and realize we're going to make mistakes. The teacher's going to make mistakes on these. It's tedious, and towards the end you get tired, and that's why you slip off and you want to get done too quick. Let's see if we've got it right now. Second time around. So it wasn't too bad to fix it. What I hope you see from this, start from the middle, work your way out, and try to organize your scratch paper because it's very likely you can make an error, transposing numbers or anything. But if you've got your scratch paper, you can come back and get those things fixed, and you'll be fine. This case is probably not a big deal, but if it's your research project, this is going to get you your master's degree or your doctoral degree, or you're going to publish it in a, for everybody to see, you're going to want to make sure your numbers are all correct. Okay, so those are kind of the two types: the fill in the Venn diagram, and the other one is they give you a Venn diagram and use it. We've done both of those. The beginning part is those set theory things of counting number of elements and constructing the sets, unions, intersections, subsets. But that's all there is to this, and it's kind of a valuable tool. And I've had students in the past use this as the mathematics for their projects, because they did some sort of project that involved categorizing things. Venn diagrams are great for doing that. So one of our last units, and again, we did use some of these when we were doing probabilities, but we were able to go by without it. But you might want to return, if you haven't done the probabilities after doing this, it might make those a little clearer. It's all good. Any other questions? Good, because we're right to the end of class. You think this was helpful? Hopefully. Okay. So as you start getting closer to the end, you might want to pull up that practice test for the final and start looking at those. I will start working on videos chapter by chapter, and I will get those posted, and so you'll start seeing those, and I'll put links to them underneath there, and just start reviewing. And you'll see there's somewhere between 3 to, actually some of the chapters only had 2 questions. I think chapter 12 had the most. It had like 4 or 5 questions, but there's somewhere between 2 to 5 questions for each of the chapters, and they're testing you at the basic level. They're not taking the most challenging stuff. So as you start looking through there, you'll see that the final is really just kind of, did you learn enough of a few things? Start working on your final projects, or at least getting some ideas for final projects. And remember, there's 2 parts to it. There's the presentation part, which a lot of times is the easier part because you're just talking about something you're interested in anyway, how math is involved. And again, don't worry about trying to teach us how to do the math. What we just want to see is how the math is used. So you don't have, we had one last week, Math in Art, and she did a good job of showing us the pictures and how those ratios were in there without doing a lot of calculations that, we don't really need to see. We just need to see how it's connected. And then you write a paper, 2.5 to 3 pages, double-spaced, that basically does the same thing. You're just communicating it in writing as well as orally. And you get help from the Writing Center on that, help from someone else. But just those 2 components, and that's 250 points. That's a 25% of the class right there. And it does help. Get the points, get the extra credit. And I'm going to open up this week, in my announcement I made mention of it, I will open up the Mayan math videos. There are some videos that you watch, and then you give me I think a 2-page double space, which is really only 1 page. You give me a feedback on what you found interesting. So there's really no wrong answers. You just have to watch enough of the videos that you get an opinion about what was kind of interesting about the math that they did. And the reason I do this is when I've studied about Mayan math, it's kind of cool, but they make it appear like we've always known this. But 30 years ago, they didn't really know what Mayan numbers were, and there was no books written, because you'll see in the videos, the Europeans that came over, they burnt most of the books because that the Mayans had. They had really good books, but they burned them all because they thought they were the devil's books, or whatever. People were keeping their culture, but there was a few that were left over. And so what's cool is that you'll see a 10 or 12-year-old boy who helps break this, that professors weren't getting it right. this 12-year-old boy. You'll see a housewife from somewhere in the Midwest who got involved and broke some of the code. You'll see a Russian mathematician who was communist, and so they said, what could the Russians know? He's a communist anyway. We don't believe him. He was right. The professors who had thought that they were right were actually wrong. And again, it's because there was these things we had to figure out. The record was not kept. And even because of what was done to the Mayans, the Mayans are still here. They still speak their language, but their culture had been stripped from them by the colonization. So it's a good story about how a people actually got their culture back because people went in and used scientific methods to break these codes by looking at patterns. And does anyone remember about the year 2012? What was that? That was supposed to be the end of the Mayan calendar, and everyone was thought maybe that means it's the end of the world. Well, it's just that was the end of their calendar. They just, the Europeans came over and took their culture away before they could make the next one. So the world didn't end. At least I don't think it did. In 2012, we're still here. But it's a great story because it has all of these components, and you can pick out the ones that you found interesting. So I'll put them. It's actually in Canvas. I just have to activate it. What you get if you write that paper is 40 points, which is one whole chapter. What it allows you to do is you could skip if you found a chapter that you really didn't want to work on, you could not do it, or you could use it, do everything else, and have 40 points of extra credit.
So is that what your email was about?
Yes.
Okay.
And I sort of was a little ambiguous on purpose because I was saying about 200 points. So I had some people asking, where's the 200 extra credit points? I said, well, it's not 200. You've got to get to 200 points to get the extra credit. So by getting to 200 points, and if you've already gotten there, great, you've got the 40 extra credit points too. So it's kind of just the way it worked out. I want to get everyone started because some of you got 1 or 2 units done, so you're at 40, you're at 80. That's okay, it still can be done. I just want to put a little bit of a fire to get you going so that if you can get to 200 points now, I'll give you 40 points of extra credit, which means you have 1 less to do if you want, or count it for extra credit, and it's going to make the final part easier for you. I have had students who have completed the whole course within 2 weeks, but they do it at the end when they have all this stress, and I don't think they've enjoyed it very much. They haven't said nice things about, no, it's not about me. They realize they put it off too long. So I'm just trying to get you going so that the last part can be more smooth for you. But by doing that, so you can pick up 40 extra credit points just by getting to 200 points within the next. So this 1 week is gone. This weekend I'll update. If you've got the 200 points, you'll get another 40 on top. But there's a whole nother week. So by the end of this 2 weeks, if you can just get to, bless you, just get to the 200 points, you'll get 40. Watch the Mayans, you get another 40. There's 80 points of extra credit. That's probably more than I should give out, but I figure I can give up to 10% extra credit, and that's only 8%. And then I've got a few other things in there if you did the beginning stuff. And so it's about, I typically will give out. And I don't think of it so much as extra credit as alternate credit, because that unit on the Mayans, if you do that, I believe that's about a unit's worth of work. It's different work because you got to write about it, but you're watching and you're synthesizing some things and you're putting your ideas. I think that's just as valuable as anything else. So it's alternate. You could basically do it instead or do it on top and have it place some points on the final exam if you don't like having to do the final exam so much. And then again, maybe if you get your final exam or your final project in early, you get those points, you can see where you're at. And we'll just go from there. Okay? All good? Okay, we just keep rolling, and next week we'll take a look at Chapter 2, which is units, and then week after that we'll look at geometry, and then we're done with the content of the course. Time to review and put everything together. All right, thanks.